In this video, we are going to work on solving multi-step linear inequalities. So, solving multi-step inequalities is just like solving one-step inequalities. We follow the same rules of equations, except for if we divide or multiply both sides by a negative. If we do that, we then have to flip the inequality symbol. So, let's take a look at these and see if we can solve them down for one inequality and then graph it on a number line. So this first one I need to start by undoing the order of operations backwards. So I know that I need to start by subtracting 3 from each side. So I have 2x is less than 6. Then I need to divide both sides by 2. Notice I'm dividing by a positive, which means my sign will not flip. And I have x is less than 3. So if I go to my number line, plot a couple of numbers, I have an open circle at 3, and I'm going towards the numbers smaller than 3. All right, so if I now take a look at the second example, I notice I have x's on both sides of the inequality, so I want to get them together. So I'm going to subtract 3x from each side to start. When I do that, I get 1x minus 5 is less than or equal to negative 7. I'm going to use keep change here so I don't lose anything. I then want to get the x alone, so I'm going to add 5 to each side, so these cancel out. So I'm left with x is less than or equal to negative 2. So I'm going to go to my number line. Here I have negative 2, 0, and negative 4. I put an open circle at negative 2, and then I want the number smaller than negative 2, so I draw the arrow to the left. All right, if I look at the next example, I'm going to start by distributing that negative 3. So I have negative 3x plus negative 6 is less than negative 12. Notice that a distributive property of negative 3 does not multiply both sides by a negative. It's just multiplying one, so our sign doesn't flip. Then we need to get x by itself, so I'm going to add 6 to each side to get those to cancel. So I have negative 3x is less than negative 6. I then need to get the x alone, so I divide both sides by a negative. Notice I'm dividing both sides by a negative 3, which means that my sign is in fact going to flip. So I'm going to move that down here. I have x, the sign is going to flip, is greater than negative 6 divided by negative 3 is 2. So now if I go to plot, I'm going to put a number at 2. There's the 4, 0. I put an open circle at 2, so that's my open circle there, and then I'm going to go to the right because I want the numbers bigger than 2. All right, and finally this last one here. I notice I have x's on both sides of the inequality, so I'm going to start by adding 3x to each side. Those cancel out, and we're left with negative 2x is less than or equal to 10. We're then going to divide both sides by a negative 2. Notice how we are dividing both sides by a negative, which means our sign is going to flip. So we're left with x on the left, and on the right we're left with negative 5. So then from here, we're going to go to our number line. So I have a couple of different numbers I'm going to put on there. I have negative 7, negative 5, negative 3. I put a closed circle at negative 5, and then I want numbers bigger than negative 5, which means I go towards the negative 3. And finally, two special cases to look at when solving multi-step inequalities. So let's start with this first problem here. Hopefully your gut is telling you to distribute, so we will do that, and we have 8x plus negative 8, I'm going to use keep change there, is less than 8x plus negative 8. Then from here, I want to get my variables together, so I'm going to subtract 8x from each side, and 8x minus 8x gives me 0, which means that undoes each other, and that undoes each other. So we're left with negative 8 is less than negative 8. And this is where we have to think a little bit more than the equations we've solved. So here we can see that we have no variables. All of the variables have undone each other, and we're left with this statement here. Negative 8 is less than negative 8, and that I know to be a false statement. -8 is not less than -8, it's equal to. What that combination tells us, no variables plus a false statement, is that we have a no solution case. So all I would expect you to do here, if you notice this happening, is write no solution, and then you do nothing on your number line. All right, if we then look over at the second example, we're going to start by using the distributive property. So we have 3x plus 4 is less than or equal to 3x plus 15. We then want to get our variables together, so we're going to subtract 3x from each side. And what we notice happen is that the variables undo each other here as well, and we're left with a statement of 4 is less than or equal to 15. So essentially here we have no variables, and we're left with this statement right here, 4 is less than or equal to 15, which is a true statement. And since we're left with this true statement, what we can say is that all real numbers will work in place of x. What this is telling us is that we have an infinite number of solutions. Essentially, all of the real numbers that exist will work inside of that inequality, and as a result, on your number line, all I expect to see is you can plot -2, 0, and 2, and just draw a line going in both directions to indicate that all real numbers will work in place of x there.